Okay, grade 8 probability. This is your test, so make sure you have your corrections done tonight and passed in tomorrow, Friday, the 25th. The first question gives you it's true false based on this particular table. And actually, the first question says, what is the probability that neither dice has a 2 showing? So the red dices are here, 1, 2, 3, 4 on the red dice, and then 1, 2, 3, 4 on this one here. So the probability that neither dice has a 2, I'm going to circle them. That doesn't have a 2. That doesn't have a 2. That doesn't have a 2. Everything else on that second row does. This doesn't, this doesn't, this doesn't. This doesn't, this doesn't, this doesn't. So if I count those up, I have 9 out of the total of 16, which makes my answer B. There are 9 possible combinations out of the 16 combinations that are not showing a 2. The rest that aren't circled have a 2 in them. In the second question, it says, what's the probability that the same number appears on both dice? So I'm going to take this table again. I'm going to paste it. I'm going to say, what is the probability that the same number appears on each dice? So there is one question, I'll move this over here, that both numbers have the same 1 and 1. That's 2 and 2. That's 3 and 3. And that's 4 and 4. So out of the 16 possible combinations, 4 of them are the same. Now, if I look at my choices, there isn't a 4 out of 16. But if I reduce this down to lowest terms, it would be one chance out of every 4 possible combinations is going to be doubles, which means your answer is A. In your third question, so the third question says, what is the probability, I'll move this over here again, that the sum of the 2 dice, now sum means you add them together, is less than 4. So if I took this one and added those 2 dice together, that would be 2. That sum is less than 4. That's 3. This one is 4, which doesn't count because it has to be less than 4. That's a 3. And the rest of them are all either 4 or higher when I add the face value of the 2 dice, which means that of the 16 possible, 3 of them are less than a sum of less than 4, which means D, 3/16 is the probability of having a sum less than 4. And your last question to do with that table, I'll paste it right here. Okay, it says, what is the probability that the red die is larger than the blue die? So this one here, this is your red die. So this is a 1. The first number is your red die, and the second one is your blue die. So in this particular combination, 1, 1, they are the same, which means that is not larger. This one, it's a red die 1 and a blue die 2. So nothing on this row here has the red die being larger than the blue. Now in the second one, 2, 1, the red die is 2, the blue die is 1. That is larger. 3, 1, 3, 2, those are larger. And 4 on the blue, on the red, 1 on the blue, 4 on the red, 2, and 4 and 3. That means there are 6 out of the 16 possible combinations, which in lowest terms, if I divide by 2, is 3/8, and therefore B is your probability. For question 5, since a standard 6-sided die is rolled 3 times, use multiplication to determine the probability that one or 2 appears on the first roll. So their first roll, a 1 or a 2, there are 6 possible numbers. And if it's a 1 or 2, that is 2 possible numbers out of the 6 on that first die. For your second roll, it says that only a 3 appears in the second roll. So there's only 1 3 out of that 6-sided die, so there's only a 1 chance out of 6 that a 3 will appear. And for the third roll, or the third die, an odd number, there are 3 odd numbers on the dice of 6. There's a 1, a 3, and a 5. Or 1, a 3, and a 5, yeah. If you multiply those all together, 2 times 1 times 3, and 6 times 6 times 6, you get 6 up top, and you get 216 on the bottom. In lowest terms, because both are divisible by 6, you get 1 chance out of 36, or approximately 2.4%, or something like that. Question 6 says, my wife and I are having an argument. I think I spelled that wrong, but anyway. There's a 10% chance that I'm right, and there's a 90% chance my wife is right. What is the theoretical probability that we're both right? And I'm aware that she's always right anyway, but the probability that I'm right is 1/10. The probability that my wife's right is this. So if I multiply those two, I have the combined probability. So 9 chances out of 100, theoretically, we would both be right. So the answer is 9%, or 9 out of 100. The next question says, 2 standard 6-sided dice are rolled. Organize the sample space in a table. So We're going to make our table. We're going to place 1 to 6 at the top for the first dice. We're going to place 1 to 6 for the second dice down there, and then we're going to fill in our sample space. So once I fill in your table, this is what it looks like, and we know that there are 36 possible outcomes, and they're all listed there in the sample space. It says, I have 26 pairs of loudmouth pants and 14 loudmouth shirts. Therefore, there are 40 different combinations of pants and shirts. The answer is false for this one, and here's why. Actually, hold on, I think I missed some questions back there. Yes, I did. Oh, my heavens. Right here. I knew I forgot something. Ooh, back up here. So it says, what is the probability that the sum of the two numbers is 10? So I'm going to take my blue marker here and go the sum of two numbers. So I got to take the digits and add them together. This one here, 4 and 6 is 10. 5 and 5 is 10, and 6 and 4 is 10. There are no other two pairs of the 36 that are a sum of 10. So that means there are 3 out of 36, which in lowest terms is 1 chance out of 12, which as a percent, 1 divided by 12 is 8.3%. Repeating, or a better way, since we did a test on it, 8 1/3%. It says, what's the probability that the two numbers are identical? So again, if I go up here and take my green marker and circle the identicals, I got 1, 2, 3, 4, 5, and 6. So for that one, identical numbers, there are 6 out of the 36, or in lowest terms, 1 chance out of 6, which is 16 2/3%, or 16.6 repeating, or 16 2/3% chance that happens. And finally, what's the probability that the product of the two numbers is a multiple of 10? So remember, multiples of 10 would be your numbers 10, 20, 30, 40, 50, and 60, and so on and so forth. So we're looking for numbers that have a product that are one of those numbers. So I'll take my black one this time, and I'm going to look for products of 10. So 2 and 5 is 10. That's a product of 10. 4 and 5 and 6 and 5 are. So is 5 and 2, and 5 and 4, and 5 and 6. I think that's all of them. So we have 1, 2, 3, 4, 5, 6. Again, just like the last one, we have 6 chances out of 36, which would follow the same path and be the exact same percentages. 16 2/3% chance. Back to the one I had before, the answer is false, and here's why. If you look at the possible number of pants, that's 26, possible shirts, we don't add them. To get the possible outcomes, you would multiply those two, which we think is 364 combinations, not 40 different combinations. Question 9 says, on Friday, there's a 60% chance of rain in Summerside and a 40% chance of rain in Charlottetown. The probability that it will rain in both cities is 50%. That is false, because we don't take the average of the probabilities. We have to look at each event and do the product of each event. So 60% would be 60 out of 100, or a better way to think of it is 6 out of 10. That's still 60% chance for Friday. For Saturday, it is a 40% chance, or 4 out of 100, or roughly 4 out of 10. So I can put that over here. And if I want to find the combined probability, we would multiply those two together. 6 times 4 gives me 24. 10 times 10 gives me 100. So therefore, for Friday and Saturday, the combined probability is not 50%, but rather a 24% probability, theoretically, that it will rain in both cities on that day. Question 10, the probability of heads with 3 coins. Let's just do that real quick. So using the multiplication method, heads for the first coin is 1/2, heads for the second coin is 1/2, and heads for the third coin is 1/2, and that combined probability for the heads is 1/8. And if I think of the spinners labeled 1 to 4 each, there's 1, 2, 3, 4, and then 1, 2, 3, 4. The probability of a 1 is 1 out of 4. Probability of 1 is 1 out of 4. The combined probability for that is 1/16, which is a less likely probability. So therefore, the answer is false, because it's more likely to go heads than it is to spin a 1/1. And finally, this picture has 9 possible outcomes. Well, in the first spinner, there are 3 possible outcomes, a 1, 2, or 3. In the second spinner, there are also 3 outcomes. In the third, there are 3. We don't add them together, we multiply them. 3 times 3 is 9. 9 times 3 means there are 27 possible combinations, not 9 for number 11. So therefore, it is false. Question 12 says flipping heads twice in a row using a coin is 25%. So again, this is one of the most basic ones we had. This is your first time. This is your second time. If we multiply that out, the probability that it'll be heads twice in a row is 25%, or 1/4, and therefore it's true. And the next one you didn't have to show any work for, because the formula for probability is favorable outcomes divided by possible outcomes. That is a true statement, so you just had to circle true, and that was the end of that. So for your multiple choice, I'm going to just match them all up for you. Okay, my apologies for how small it is and stuff, but if you press pause here, you can find all the combinations for the answers. They're all there. The most difficult one to read is the dependent event, which are really small, but the results that are impacted. So just match those up. Those are your definitions. And that, ladies and gentlemen, is your test in a nutshell. So hopefully you make your corrections, bring them in tomorrow. Make sure you have on one side of the paper what I did, and then on another side of the paper you had what I should have done. Don't just make the corrections on your test. Have a separate piece of paper that shows me what you did and what you should have done so you learn from your mistakes.